Automatic, Addison.
In this tutorial, I'll show you how to use GTest, Google's C++ testing framework. We are going to explore how to write and run tests for ROS2 nodes, ensuring your robotic software functions correctly at the component level. By the end of this tutorial, you'll be equipped to implement comprehensive unit tests, enhancing the reliability and maintainability of your ROS2 projects. Why use GTest? Well, imagine you're building a complex robot using ROS2 with multiple C++ nodes working together to control its behavior. Every time you update your code, install a new version of ROS2, or upgrade any dependencies, something could break without you realizing it. This is where GTest comes really in handy. So GTest, think of it like a safety net for your robot C++ code. It automatically checks that everything still works correctly after you make changes. For example, if you update your navigation code or install a new version of a sensor driver, GTest can quickly verify that your nodes are still publishing the right messages at the right times. This helps you catch problems early before your robot starts behaving unexpectedly in the real world. Let's write a basic unit test for the ROS2 C++ publisher node we created in an earlier tutorial. The test code we will write sets up a testing environment for a ROS2 publisher node, making sure it can properly start up and shut down. The first test checks if the node is created with the right name and is publishing on the correct topic. The second test verifies the node actually publishes messages with the correct Hello World format we expect. So I have a terminal window open. Let's go to our ROS2 workspace. And we need to create a new folder. We're going to do, let's go into the package first, cd ROS2 fundamentals. Okay, cd test. And we've got our PyTest from the previous tutorial. And now we need to use GTest, make dir GTest. Now we've got GTest in there. All right. So let's go back to the package, clear, code period to open Visual Studio Code, which I'm going to use to create the code. Okay, and follow along with me, click by click, keystroke by keystroke. And remember, slow is smooth, smooth is fast. If you go slower, all right, you're going to go smoother. And if you go smoother, you're going to go faster in the long run because you don't have to go back and fix all your mistakes. There is no rush. Enjoy the journey. Enjoy the journey. There's no rush when we're writing code. Take your time. Make sure you do things right the first time so you don't take longer in the long run. So now I see my test folder. I see my GTest. And let's create a new, not a new folder. That's me going too quick. GTest, let's create a new file and let's call it test_publisher.cpp. All right. So we've got our blank CPP node. Okay, let us start by creating our header as we always do. So let's do that at the top. And let's do at file. Actually, to make all of this easier, I'm going to copy a header that I already am using. So test_publisher.cpp file, and then at brief unit test for the ROS2 minimal publisher node. So this file will contain test cases, and what we want to do is verify that the node is created correctly. All right, and then we want to publish the expected hello world message. So we're going to do test node creation, verify the node publisher is all good, and then verify the message format, and I'm going to type the new date. So let's do April 12th, 2025. So we got our header all set up, ready to go. We need to close this. Save. Okay, here is our header in all its glory. Now let's do the necessary header files. Pound include, and then GTest, GTest.h. I'll do pound include, RCL CPP, RCL CPP.hpp. Now we do pound include. Let's bring all of this over, by the way, over to here. All right. Pound include, and then stood message, string.hpp. Okay, everything looks good. Now let's do our class. We've got to do our class. Okay. Class. Okay, and we're going to call this class. Let's think what we should call this class. Class minimal CPP publisher. Okay. And now what we want to do is to do I'll show you what we're going to do here. We're going to type this. So type this pound define, and we're going to do testing underscore exclude underscore main. Okay. And then we're going to do pound include, and then forward src forward, and then cpp underscore minimal underscore publisher dot cpp. Okay. So what this does, this pound define testing exclude main, this prevents the main function in the implementation file from being included, which could conflict with our test main function. So when we include this file, cpp publisher.cpp, it's got its own main function right here. All right, its own main function. And we don't want this main function to be included when we import it. So that's why in our test publisher.cpp, we do this testing exclude main right there. All right. We don't want two mains. C++ starts to bark at us when we do. So let's create a test minimal publisher. So let's do class. So this class will set up and tear down the testing environment. We have to initiate ROS, create our publisher node, and then clean up afterwards. This gets everything that we need going. So I'm going to call it test minimal publisher public testing test. Okay, go to new line, it's curly braces, and let's go over here, protected, void, setup, override, curly braces, and it RCL CPP, init, 0, no, PTR. Okay, and let's do node equal stood make shared minimal CPP publisher. Okay, all good so far. Okay, and close out our curly braces. And let's go to void tear down, override, node.reset, RCL CPP shutdown. Okay, and then we need the node that we're testing. So stood shared pointer, as we always do, and then minimal CPP publisher node. Close that out with a semicolon. Everything good up until now. Now let's test the node creation, shall we? Test the node creation. All right, let's do that now. Test underscore F. All right, we're going to test minimal publisher. I'm going to test node creation. Okay. We're going to verify that the publisher node is created correctly. That's the purpose of the test we're creating. Publisher that publishes Hello World. So we do that by doing test F, and then everything goes inside the curly braces. So first, check if the node matches what we expect. So expect underscore equals EQ, and then stood string, and then node, and then get underscore name. Comma, then stood string. Okay, and the node name is, go to our minimal publisher, minimal CPP publisher. Let's just copy that. Make no mistakes. Go back to the test. And in here, stood string minimal publisher, and then 2 close parentheses and a semicolon to close things out. Oh, expect is not right. Okay. Okay, now let's get information about our publishers on the topic and verify there's only one publisher. So auto pub endpoints equal node get underscore publishers info by topic. Okay, publishers info by topic, and let's do open parentheses, semicolon, and here's where we do the topic. So we need to get that from our publisher, and we got it right here. Copy the whole thing, including the leading / go back to our test, and save. Okay, and now let's verify that there's only one publisher on that topic. Okay, expect EQ pub endpoints dot size, comma 1U. And we need to close it out with a semicolon. So that tests the node creation. So we want to make sure that the node name is exactly that name. The node name is exactly that name. And we also want to make sure that the node has exactly one publisher on the topic CPP example topic. That's just one of the tests that I'm curious and I want to perform. So now let's do another test, just like we did on our Python tutorial. Let's test the message content, okay? We want to verify that the published message creates that has the correct format. So we're going to, in this test, we need to create a subscription to capture the publish message. We need to trigger the publisher to send a message, and then we need to verify the message starts with hello world. So let's do that now. Test underscore F, and then we're going to do test minimal publisher, comma test message content, and then curly braces. And let's create a variable to store the received message. So stood shared PTR, stood messages, message string, received underscore message. Okay. Now let's create a subscription to capture the published message. Okay, and what are we going to call it? Let's call it subscription. So auto subscription equal node create subscription. Where is it? Create subscription down here. All right, and it is stood underscore messages. Okay, and the field is going to be message. And then we've got string on here. Okay, and let's do forward slash, and then CPP example topic, and we need to do comma, and then the queue size, comma. All right, and now let's get rid of that so you can see it. Take a look at that, creating our subscription. All right, and capture the received message. So follow along with me, click by click, very slow. So ampersand received underscore message, and then open parentheses, const stood messages, message string, shared pointer. Tell you, C++, it is not brief in its syntax. You got to write out a lot of stuff. So just follow along with me, hold your horses. Now we do curly braces. It's a lot of stuff to do the same thing that might just take one line in Python. So here we store the received message, and let's do stood make shared stood messages, stood underscore messages, message. Okay, and what is the message type? It's a string, and let's reference that, MSG. Woo! Oh, mama. That is a lot of code. That's a lot of symbols. Okay, and let's close that, and then that. Okay, looking good, looking good. Created our subscription. Now we need to actually trigger the publisher to send a message. To do that, let's do node, and we need to do timer callback. I think we can get rid of that. We need to process any incoming messages by spinning, spin. Let's use the spin sum, and then node. And what do we want to do? Let's check if the message starts with hello world. So expect underscore EQ, and then received underscore message. What do we want to do? We check the data part of the string message, and we're looking for sub string, and let's do from 0 index to 12. Okay, and then comma, and then in parentheses, hello world. Okay, and let's do the exclamation point, and then close that out. Woo! A lot of code. Hang in there, folks. We're almost done. So now let's do the main function down below. Below all of this, below our test. So int main, open parentheses, int argc, char argv, curly braces, do testing, and then init GoogleTest, ampersand argc, comma argv. And then return run all tests. Save. That is a lot of code. Here's the main function again. Okay. And so that function, we are initializing the GoogleTest framework on this line 77. And then on line 78, we're actually running all tests. Now let's go over to the C++ publisher. All right. And let's take a look at it. We need to go down to the make sure your main function. Okay. So we need to have this piece of code before the main function. We need to wrap the main function in this testing exclude main. So we need to make sure that this main function is not included during testing. So we do the pound if in def testing exclude main. And then below the main function, you do pound end if. Make sure you got it, folks. You want to skip this main function because you're including it in your test file. You can't have two main functions, or else your system will get super duper duper confused. Now that we've written some new code, let's go over to CMakeLists.txt and let's go down here to the bottom and let's check it out. Make sure everything looks good and checks out fine. So let's go down. All right. Down to the if build area. Let's just take a look at it. So we can just comment that out. We don't need it. PyTest, GTest, looking good. All right, and then we've got our Python tests. Let's look at our C++ tests. We've got a mint add GTest, CPP minimal publisher test, and then you want test GTest and then test underscore publisher.cpp. So this is where we include our tests. Make sure you have that, and then make sure you have this line up here to include the mint CMake GTest. Need both of that. And don't forget, so when we have a C++ program, we need to add dependencies for this executable so it can find it. And you do that with mint target dependencies and then CPP minimal publisher test and then the dependencies and then indef. Just take a moment, make sure you got it, make sure it looks good. Take your time, go through it, look for errors. Make sure everything is good. And when you're done, you can save it. All right. Okay, and now let's go over to your package.xml. Make sure you have this line, mint CMake GTest, down here below the mint CMake PyTest. Make sure you got it. All right. And now just clear out everything. Go to the root of your ROS2 workspace now. Make sure you're in it. Okay, and type build. Let it build. Everything built very cleanly. It's always good when this says starting and finished. Built with success. That's what you want. And after you build, we now need to source. Let's source the bash. Let's source.bashrc, source the terminal, or you can just open a new terminal window. Either one works. And let's run our test. So now for the moment you have been waiting for. So you're in the workspace, do colon test, and then do -- packages -- select, and then ROS2 fundamentals _ examples. So we're now running the tests. All right. And looks like everything did pretty well. So if you want to see details of the test that actually ran, you would do colon tests, this packages select right here, the name of the package, and then let's go to space and then hyphen hyphen and then event handlers space and then console and then underscore direct and then plus. Ooh, Nelly. 0 tests failed out of 2. So remember, we did our 2 tests. Remember that? Test 1 and test 2. And we go over here, 100% of the tests passed, 0 tests failed out of 2. Looking all good. Looking all good. Yeah. CPP publisher, 2 tests from the test minimal publisher. All right. It's exactly what we wanted. So there's a lot of gobbledygook in here. It's a lot of gobbledygook. But what you're really interested in is the CPP minimal publisher test results. And if you kind of go through here, you can see it's running 2 tests from 1 test suite. Okay, and it's looking at the CPP minimal publisher test. 2 tests from the test minimal publisher. It's exactly what we expected, test minimal publisher. Got 2 tests, the test node creation and the test the syntax, the actual message content that we get hello world. Okay and okay. And you can see our 2 tests here, 1 and 2. And they both pass with flying colors. That makes me happy. And you can see up above from our previous tutorial, we actually ran the Python tests as well with the minimal publisher test from our Python example earlier using PyTest. But everything's working just as we expected. And now to actually take a look at the test results, you'll do colon test result and then all. This is 2 tests, 0 errors, 0 failures. Lots of tests. And this is all of our test results. If you want to see something a little bit more verbose, you can do add verbose, means more data. Okay, just get more data in the output. So that's it. That is GTest for you. Very good way in C++ way to unit test your code. Thanks for watching. Thanks for following along. Keep building.